So you'll note we've skipped over 3.2. We're just moving right into 3.3. And even there, I've condensed this down. I've skipped a few bits and pieces. A lot of the most effective way to draw a scatter plot is to use something like a computer or a it's tedious when you're doing it by hand compared to when we get to linear equations and relations, but and we won't likely have much access to computers in a lot of cases, so we're going to avoid some of that. If you're interested in learning how to do scatter plots using a computer, if you follow through in the textbook sections 3.2 and 3.3, you'll find some good information using software like Geometer Sketchpad. And then you can also do it in programs like Excel. It's fairly easy, and you can look that up online. More so, we just want to look at some of our key definitions here for this section. So when we're talking about drawing curves and lines of best fit, we just want to look at the types of relationships we have. So we got two main types of relationships when we do find a relationship between the data. It's either going to be a linear relationship, which occurs when all the points on a graph tend to form a straight line. So if we got a graph and we got some points and they're kind of in a straight line, we could kind of say, yeah, they're close to that line. It's probably a linear relation. We got a linear relationship there. And then in the case of a non-linear relationship, it's when they don't form a line, and it's likely going to be but there is a relationship. It's likely going to be curved of some sort, so it would form something maybe like this. This rainbow type of look here, or it could be something like this, where it's kind of curving up instead of a straight line up. It just depends on the situation. So we either have a linear or non-linear type of relationship, and then the line of best fit is that line that I've drawn there. So I've drawn that line, it kind of fits closely to the data. So the idea is that it's a straight line that represents the trend in the data, and it would pass through as many points as possible, ensuring that half are above and half are below the line. So in general, this would be a good estimate on a line of best fit for this data. We have this scatter plot here, and then this line here in blue is a good representation of the data. In general, there's enough above and below. If we did this on a computer, we could get it more exact. And then we can use the point of having the line of best fit, and in the next case, the curve of best fit here, which is just a curve doing the same idea as the trend for nonlinear data. And the point of these is that we can use these to make estimates and the model. So we can say, okay, in general, this is what's happening. So if we pick any random value, say one in the middle here, or we pick one that maybe exists outside, what happens if we keep going forward here? What would happen over here somewhere? And we can say, well, the graph keeps going and it's going to hit this value. So we can use these to make models that we can use to estimate what's going on with our data and make predictions. And that's what's called mathematical modeling. We use that in many instances to make judgments and predictions of what's going on. So those are pretty much the key ideas in regards to scatter plots and working with data relationships.